I believe robots will build the world.
What exactly do these robots look like? Have they got sort of arms and legs? Are they sort of humanoid?
Elon said physics is the law, everything else is a recommendation. So we abide by that.
Today, I'm very privileged to be joined by Russell Varone, the CTO and co-founder of Diamond Age, a company that's reimagining the future of domestic and general construction. Welcome to the show, Russell.
Hey, thanks, Tom.
What is your wildest prediction for the future?
You know, Mark Andreessen, famous quote of his, software is going to eat the world. I believe robots will build the world.
Wow. Like everything?
Everything. Yes.
Like our
Houses.
food, our pizzas, our clothing?
Eventually, yes. And my focus right now is on homes. And then in the future, we go to residential, we go to retail, we go to streets, we go to bridges, we go to power infrastructure. I really truly believe that robots will end up building the world in the future.
I love it. I have this little game I do called a change safari
Okay.
in my presentations. And the idea is that I ask people to walk around the world and to imagine what they see today that looks wildly different from 30 years ago. And it's extraordinary how little has changed. Like software has kind of eaten the world, but it's a kind of background element. The built environment seems extraordinarily slow to change. Why do you think that is?
I think that it's the hardest thing. It's out in the elements. It's, taking a lot of big things and cutting them and fitting them into small things, and nothing is precise. So the resistance to change is due to the fact that it's hard. Building houses is hard. Ask any construction person. It's not an easy job. It's a great job. It's an amiable job, but it's hard. So no one's gone after that. Where you see automation, you go into a factory, controlled environment, assembling cell phones, right? Building cars, building aircrafts. Go out and do that in the mud and the rain at 30 degrees, Fahrenheit in the morning, in the summer in Phoenix, in the winter in Phoenix, or 125 degrees in the afternoon in the summer, right? Really, really hard, and people are shying away from hard problems.
And you're taking this on, I believe.
Absolutely. Right?
So what does Diamond Edge do?
We automate construction. So we are bringing robotics to the field to build houses better, faster, at a lower cost.
Is this one of those sort of 3D printed concrete things, or is it a little bit beyond that?
It's grossly beyond that. If you look at 3D printing of walls is about 10% of the house. And if you refer to Amdahl's law, I don't know if you're familiar with that. It's a computer science law. Gene Amdahl back in the 60s said, if you take any problem and only solve a portion of the problem, you'll never solve the problem. So if I took 10% of the walls of a house and did that with a robot perfectly, and it was 50% better, I've only made the house 5% cheaper and 5% faster. Why bother? You have to go after 100% of the house with robots. That's an aspirational goal. And right now we're heading there, right? We're at like 25% of the house is being built with that. And it'll take us a long time to get to 100%, but we're not going to stop because the world deserves it. I see we need it. And that's why we founded Diamond Age, to be able to go out and automate homes, and then in the future, all sorts of other construction structures.
So how does this work? What exactly do these robots look like? Have they got sort of arms and legs? Are they sort of humanoid? What parts of the process are they part of, and what are they unable to do at the moment?
The easiest way for me to explain that is it's a big candy crane, right? About 15, 16 meters wide, right? About 28, 30 meters long, about 7 meters high. So it looks like what would unload containers at a port. Big superstructure. Then we actually have two robots that carry tools around. We have one robotic arm that looks just like a spot welder you'd see in a Tesla factory. Then we have another robotic arm that's very, very specific. We patented, but it carries big, heavy tools. So we carry around a concrete printing tool, or we can lift roof structure, or we can lift big, heavy sheets of decoration for the side of the house, like sheets of stone or faux stone. So it's this candy crane times 100. And it actually starts when the house is just a foundation. We actually use LiDAR and we scan the foundation so we know exactly what the house looks like. Then we take it through a whole process of, we build the walls, we inject insulation into the walls, we cut door and window openings, we load the roof on, spray waterproofing and finishing and paint. So it's a multifaceted process. It's just not kind of squeezing peanut butter like concrete out of a tube. and building some walls. So we've looked at the system and said, we have to be able to aspire to 100%. And we built a system that uses existing materials, concrete, stucco, paint, insulation, and builds it in a different way like you would inside a factory.
So, of all the components that you're talking about so far, you're not using your own sort of proprietary concrete mix and your own sort of special type of, fireproofing. Like everything that you are building with is stuff that's sort of theoretically somewhat off the shelf.
Yeah, we call it local supply chain. Like, anywhere you go, construction is hyper local. Europe, Asia, Africa, US, no one trucks in heavy, big things from thousands of miles away. They go to a quarry 20 miles away. So we set it up where we use local materials, and we've made the equipment so that the equipment can handle that, because construction's hyper local everywhere in the world.
And I have to be honest here, for those listening, I do have a sort of slight vested interest in this because I sort of own a piece of land in Miami that it's been my intention to sort of build a house of the future on. And I've spent years looking into various prefabricated solutions, sort of ADU, sort of modular construction, 3D printed walls. And everyone I've ever talked to has sort of said, no, this stuff isn't ready. But this seems sort of somewhat different. Like it seems like a much more holistic solution. So if I was to sort of bring you onto my site right now and you were to sort of admire the various beautiful trees around, what would your company start to do? Like, would it do the foundations? Would it build the walls? Would it build the sort of superstructure, the insulation, the electrics, or do you do the second fit? Like, at what point does the sort of process get handed over to other people? And is your long-term aspiration to be able to do everything in one go?
Yeah, the long-term aspiration is absolutely do everything. That's a very, very big goal. So it's going to take some time to get there, but we'll never give up. But if I walk down into your land, you tell me what you want to build. I don't really have build constraints, so we can build pretty much anything you like within reason, as long as it fits inside the machine. And we would traditionally, just like they pour a foundation, concrete trucks come out. Eventually we'll automate that, but today someone builds a foundation for us. Then we start with the scanning process and we print the walls, but we build the house layer by layer. So if you've ever built a dollhouse, like my dad built a dollhouse for my daughters, and you build it as you go with the roof off. So as you get to something like 400 centimeters above the floor, you put in the electrical outlets, right? We cut those in. And then as we go up, as the wall gets to a meter and a half high, we put some of the electrical conduit in. So the walls actually grow and all of the parts of the walls are populated. We get to the top of the house, we finish that out with insulation, and the conduits and the channels for plumbing and electrical are already in the walls. Then we start with spraying stucco on the outside or waterproofing on the inside. So you build this house kind of top off with no roof on it to go as far as you can, depending on weather conditions. Then we actually place the roof on the house, and we can put the trusses on, the structure that holds the roof up, the sheathing, the shingles, and we can spray paint the house. So it's very similar materials. We don't use anything different. It's just a different approach, and we've re-engineered the means of using off-the-shelf supply chain stuff. So everything you build in a house, you're in the US here, may not know it, I don't know some of the home supply stores in Europe, but go to a Home Depot or Lowe's, any window in any Lowe's I'll put in the house. Any roofing tile I'll put on the house. So we try to use things out of the existing supply chain so we don't have to be special.
And is this all your company's idea, or has this been done by other people as well?
We got inspired by one of the leaders in the field on the 3D printing, and we said, it's a big, expensive machine, and it's hard to set up. Why just do walls? Why not do everything? And I've spent 30 years in factories, so I decided I can build a factory outside with a team of people we have here at Diamond Age. We said, look, instead of a car moving down a production line like I did when I worked at Tesla, we moved the tools around the machine to build the house.
I think one of the things that sort of hits me about this is there's probably no bigger problem to solve in the world than home construction. There's sort of rampant sort of labor shortages in the entire construction field. By some measures, it's the most valuable industry in the entire world. It's something that is a problem in almost every single country on the planet. Why has no one else sort of solved it already? Like, without being sort of rude about you, Russell, like how is it that you're the person that's able to provide the best solution and other people haven't kind of got there before?
Yeah, just to confirm, you're right. It is the biggest industry in the world. It's $14.5 trillion around the world. Because right now, good enough is good enough. There's not the external influence for people to say, go build it different. The home builders here in the US make a lot of money. I love them. They're my customers. But I want to be able to provide for people that are just coming up, young folks, young women and men out of school, want to start a family, buy a house. That's the bedrock of just our civilization is family, and family needs a home, right? And the people that care the most are the ones that don't have one. The people that are building in the construction industry, they're motivated by market forces. We as a team, the people who founded my company looked and said, hey, this is a big, meaningful problem. This is not delivering burritos by a drone, right? This is housing. This is a place when we sell a house, it becomes a home. People have birthdays there. They have Christmas there, memories, right? That's like connects to you on that visceral level. So we said, let's solve that. And we looked at the problem and said, if taken step by step by a really good engineering team using existing materials and existing processes, we can automate this. And it's going to be a long road and a hard road, but we're willing to do that.
What are the biggest problems that you face that need solutions? Like, is it to do with zoning and regulation? Is it to do with the sort of hyper local requirements the different places have? Is it the construction of the robots and the tolerances and dexterity needed? Like, what are you sort of mainly working on at the moment?
You hit on a lot of things in that we've just taken the approach like regulation. I'm not going to fight in the U.S. We say I'm not going to fight City Hall. The regulations are what they are. They're there to provide safety. So if a regulation is for life safety or worker safety, I respect that and support it. Zoning, I don't like, but I deal with. Right? Materials, we knew that if you were going to build houses with robots, you're already strange and weird. So you could not go upset the ecosystem and look, I'm bringing in some biofoam or mushroom based thing. People will look at you strange and go, no. So we said concrete, paint, stucco, right? Wood for roofs. And then to home in on the difficult parts, the difficult parts are actually some of the same problems that people in the self-driving space, right? Sensing, right? All of the things to figure out where the robot is in the world out in a real environment. You're not in a closed factory. Just like Waymo and Cruise have to sense and know what's around the vehicle, it's the same thing we do with the robot. So those are some of our biggest challenges, but we've solved them through integrating other people's solutions that come in from very different industries, aviation and shipbuilding. So we just looked and said, someone has solved most of our problems. We have to be an integrator and be willing to do the first step of the process of saying, let's go try it and then learn and say it wasn't good enough, but now we know.
And who are your customers? Are these sort of big developers that you're selling to?
Yeah, right now, big developers are selling too, and it's like we talk about the, robots will build the world. So right now we're building houses because that's most important to us. And from a manufacturing standpoint, homes are relatively a simple product, right? So when you start something with automation, you want to start simple and learn. And then we'll go on to retail and bridges and roads and whatever you need. So we will do the whole ecosystem of construction eventually. But an interesting thing is we're selling to home builders right now. And we also just Monday, signed a letter of intent to go help build structures in Ukraine. Structures for homes, structures for protection. So, this is not limited to just home building. This is addressing the need for automated construction that goes fast and does it better and at a lower cost. So, we're excited about that. Very excited. It shows the thesis that we won't be contained to homes, but we also have to have the laser focus of a young company to say homes are really what we want to do. But the Ukraine mission is near and dear to us. And we have people that need our help. Let's go expand our horizon a little bit and go help those folks.
Because I was going to ask about different sort of countries in a way, because homes are interesting, and some elements of home ownership are very global, and some things are very local. Like in Japan, homes are almost expected to last sort of 50 years or something. In Germany, people are less likely to want to own. In theory, is your technology such that it can be applied in any country on the planet?
Yeah, I
Or
believe
does it
so.
kind of require certain sort of space or I don't know sort of power requirements or something?
You know what? We believe we can go anywhere. Like I said, the Ukraine thing will be our first test. But you go to Asia, you go to you go to Africa, you go to South America. I've traveled a lot, right? Built a lot of factories around the world. So you have to respect those local requirements. There's certain things we're not going to do. I'm not going to try to squeeze my machine between two buildings that are 8 meters apart. It's just not going to happen. My machine is right now, I won't do that. But in the future, if that becomes the need and people really need that to solve, I have an amazing engineering, team. My team of women and men in engineering will solve that problem. So right now we've built bespoke that looks more of the large scale developments here in the U.S., the kind of the quote unquote suburbs you'd see in the U.S., right? That's what we've designed the machine for. But we can go a couple of stories high, we can go much narrower, longer, wider, and we can use different materials.
At what point do things start getting difficult? Like, obviously, if the spaces are confined, it gets difficult. Is there a number of stories or level of spanning or I know seismological requirements? Like at what point does your technology sort of stop being a good way to do this stuff?
Right now in its present state, it's early. I've got about 6 machines, second generation of our design. Like I said, we're about 15 meters, about 48, 50 feet wide, about 28 meters long, right? For the Yos in the US, about 90 something feet. That provides us access to a giant market segment right now where we're at. So that was the first version we decided to build. And that can go up to 3 stories. So, and here in the US, that covers almost 80% of that single family, multifamily housing. Like, I'm not going to do a giant apartment block of 600 units with this yet, right? Give me a few years. But, if I do something that's here in the US, a lot of light rail going in Phoenix, I'll build something that's 3 stories tall, 30 meters deep and has 6 or 8 units in it. I'd love to do that once I really get the technology of those single family homes down.
Something that you said that surprised me earlier actually was this idea that this is merely the sort of first phase. It sort of reminds me a bit of Elon Musk sort of launching the Roadster as the first car. Like, his goal wasn't really to sell sports cars. His goal wasn't really to sell cars. His goal was to sort of change the face of the planet with sort of battery technology driving that. Like it sounds like you've got a similar mission where this is merely the first stage. And if so, and you're happy to, can you sort of comment on your further plans in sort of more detail?
Oh, absolutely. Full disclosure, I worked directly for Elon for a while, so I have the battle scars, but I also have about 20 IQ points more from just osmosis. Like, amazing guy. Like, I had the most fun, except for now at my company. Just absolutely amazing experience. But yeah, we mirrored it a little bit differently. Like, Tesla did the Roadster as that exploration. We chose to go after that simple form, kind of like Tesla was the Roadster. We went after an entry level Renault or a Hyundai or a Kia, right? Because that was where the need was and the simplicity was there. We didn't want to go out of the gate being really complex and really feature rich. That was dangerous for us because everything's so big. So that's what we went after first. And then, where we go next is you think about where the biggest needs are in construction. So homes are by far the largest market for us right now. And they're all, I don't want to say rinse and repeat, but they're very close, right? A 3-bedroom, 2-bathroom house may have some walls moved, 4-bedroom, 3-bathroom house. But if I look at a shopping mall, if I look at a train station, those are bespoke. That's a one-off design. We can do those, but to prove out the technology, you want to get a lot of repetition. You want to build a bunch of houses. And we built about 25 houses so far. We have 17 families living in the houses that absolutely love it. I see them every weekend when I'm down at the job site and shake hands over fences. And just, you get the chills because you put people in a home. And, there's nothing more satisfying than that. So we can build a lot of different things. Right now, it's going to stay focused on that single family. And then as the technology matures, we'll expand.
What have you learned in this process that surprised you the most?
In this process, I think that the ecosystem of technology has really been focusing on bits versus atoms. I mean, I don't know if you know Delian from Varda Space, right? Those guys are out there. They're building, they're manufacturing drugs in space. And he said it best. We dream in bits, but we build in atoms. And people look at us kind of a little Don Quixote, like, hey, you're tilting at windmills by doing this. And we're like, that's okay. Just stand back and watch us, because software is amazing. It's not easy by any. We write a lot of our own software, but to go out and build a machine that weighs 40,000 pounds and build a machine that can extrude concrete and pick up a roof and spray stucco, that is a different level of commitment and variables. And, people the doubt, there's a lot of doubting Thomases out there. And we're like, that's okay. Like, everybody can be skeptical, but we're all optimists. We believe in an abundant future, and we're going to build it. And we're going to go build the machines that do that. We're going to trip, and we've tripped and fall. We fall on our face on a few tools and different stuff, but we're a bunch of builders. So we scrap it and we come right back to the drawing board and say, hey, we're going to solve that.
And it's quite a different approach. I mean, I know we sort of touched on this earlier, but lots of people are trying to solve this problem in different ways. Like probably the two most obvious other ways are, one, just people sort of 3D printing sort of walls, and that never seems to go further. And two is the idea that homes should be built off-site and either delivered in one unit on site or delivered in a few sort of modular prefabricated units. Do you think those approaches are both wrong and you have the only answer, or is there part of you that sometimes thinks that maybe just building homes in a factory is the way ahead?
I look at it in the first example, you have 3D printing. I think I talk to a lot of those folks. Again, it's an interesting ecosystem. Everyone is building hard, so I have respect for everyone who's struck out. I think that you have to try to solve the whole problem. I don't think that just walls moves the problem, but they do some really architecturally interesting things, and they've learned a lot. So they're pushing the idea of technology solving the house. I love that. Like, is it the right technology? History and time will tell. And then I look at the other side of that question, where you look at modular and factory built. And I'm a factory guy. I ran factories for 30 years. And that's very interesting to me. But there's things about latency. Like, if you build something today and it doesn't get installed till next week, there's distance and transportation. And the modular plays have a very, very interesting place in apartment blocks, student housing, hotels. When you look at what I'm focused on right now, single family housing, it's a much harder thing to transport 8 or 10 modules, 400 kilometers from, Central California to Phoenix, and do that intact, and, do that at low cost and timing. So I give everybody the props for trying the hard things. There's no peanut butter spread solution, that is winning right now, but we do believe that long term there will be automation that works on everything, and some of that may be in factories, some of that will be on site. So, and the housing problem is so big that as long as everyone moves the needle, it'll start to get better.
It does sound a bit too good to be true at times. Like, going to your website and reading about it, it sounds like it's sort of faster and cheaper and sort of better quality all at the same time. That seems a little bit remarkable.
Well, you get two legs of the stool, Tom. It's that three-legged stool problem: faster and better quality. And as a startup founder, the cheaper thing is why I don't sleep at night. So we're out there and we're working on that every day. But we definitely, when people come and see it, we've had the C-suites of the big publicly traded home builders in the U.S. and some folks from Europe come and go and look at the houses, and they go, okay, this is a really interesting product. The quality that you get out of it is a differentiation, right? And the robustness. And again, for European folks, like, most European homes are built from masonry. In the U.S., unless you're on the Gulf Coast, it's a lot of wood. The stoutness of the house and the quality of sound reduction. So we build a different product, and we definitely build it faster. Like I said, so you get two of the three legs of the stool right now. And when I get that third leg, then we're going to have a lot of fun conversations.
But the designs that I all saw were quite sort of, let me think of my words carefully. They're quite sort of rudimentary designs. But I guess in theory, because you're basically building the toolkit rather than the house, there's no reason why there couldn't be more interesting designs, and then further down the line, more sort of intricate designs. Or are there some sort of problems with physics that are getting in the way here?
No. Like I said, ex-boss, love him. Elon said, physics is the law. Everything else is a recommendation. So we abide by that. No, we can build some interesting architectural explorations, but in the housing crisis, people with attainable housing, right? Entry level, small, good for starting families. You go with familiarity, and people like a 3-bed, 2-bathroom house here in the U.S., some stucco on it, some clapboard siding if you go east, or brick. So you build that familiarity, because you can't bring a weird robot to something and say, weird robot only does something that looks like a yurt or looks like a stack of pancakes. Like, you'll have some people, the early adopters and the architectural aficionados go, oh, that's amazing, right? And I talk to a lot of those people and I admire them and I learn from them. But the familiarity of just that, hey, it's a 3-bedroom, 2-bath, 2-car garage. I got a picket fence. I have a dog and 2 kids. That's the goal for a lot of people around the world. And that's what we're building right now. But we definitely have the ability to go and do some interesting architectural explorations. It's just right now, stay simple. Don't get over your skis, as we say here in the U.S.
And as we sort of go back towards your prediction, when you look towards the far future and robots being used to construct things, what things do you think your company will end up making in the future? Like, what's your sort of 10 or 15-year vision for Diamond Age?
Definitely multifamily, multi-stories. I think, we can go, once you have the code cracked of being able to bring equipment to a job site, set it up, sense where you are in the world, and run those procedures that get good results of a building. Construction is like there's not a lot of difference between making a sidewalk or a street than there is a building foundation, right? This is all shaping materials and cutting and molding and so different things. So, I don't think we limit ourselves. The thing I look at is the need for the ability of this equipment in 15 years down the road is, Gulf Coast of US. My mom's down in Florida. Hurricanes come in, right? Climate is a real issue for us. You level a community, there's 2 scenarios I want to see. One, I want to see that Diamond Age built that community 2 years ago and everybody just rakes the leaves out of their yards and maybe dries out their garage. Or if we haven't built that community, when that community gets blown down or a fire runs through it out in the US West, we come in and an army of robots unpacks and rebuilds the streets and rebuilds the power lines. And that we have this sort of, if you know the older cartoon Jetsons, right? Like we have this, iRobot with Will Smith. You have this little army of robots, and there's a lot of people out there building bits and pieces of that we think we can take advantage of. So that future for us becomes, that little army of robots. It may not look like what it looks like today, a big giant frame. You have humanoid robots coming. You have a lot of great things that people are doing. So I'm super excited about the whole space. And but I think, if you said 15 years, I have an army of robots that can go recover a community, or someone wants to build a new city in California, we show up, we start building that thing. And that, you've got people there with great jobs maintaining the robots and people with software. So, I don't worry about the job aspect. We just will recreate the jobs around that. But I think 15 years, army of robots building anything you want.
I love it.
I would think, Tom, that when you think about it, is we talked a little bit. I just talked about that, like the climate impact of housing, right? So housing is the biggest problem out there, but the second part of that housing is climate change. And wherever you sit, doesn't matter. When a hurricane blows down a community, when a wildfire burns up a community, people suffer. So we've designed a product that is energy efficient and climate resilient. So you're building the house that will last, because, you can build an amazing passive house, zero energy house, super efficient, amazing design. But if it burns down, right, what's the climate impact of building it a second time? What's the family impact of losing, grandma's curio dresser and your kids' trophies, right? So we want to build things once. We want to build things that provide people safety and that resiliency. And that's where we really come back to say, when I think about climate, I think about delivering people that safety and that resiliency, because it's happening more and more. And you see people in the US, you see people in Europe, you see hot summers in Europe, you see flooding, you see Asia, everywhere around the world. People's lives get disrupted. And I think we have a duty as builders to give them a structure that provides that safety and that security, because home should be a safe space, right? And it shouldn't matter that a hurricane's coming. I'm an engineer. I can figure out how to withstand the bigger hurricane, right? And to provide that to people. And that's an exciting thing to say, look, in the near future, that's what it'll look like for people.
I think it's fantastic. I used to show a picture of a very complicated robot laying bricks in one of my presentations. And it was always an example of how we apply technology to old ways of doing things to kind of lubricate false systems of the past. And how what we really need to do is sort of reimagine these things from first principles. And I never really knew what the answer was. I always knew that the answer was not a robot laying bricks. But when I saw your technology, I thought that's, it's only when you see the answer that it becomes obvious. And seeing the work you're doing and seeing your approach towards it and seeing your your core competence in robotics being applied to construction rather than construction people trying to sort of improve their own industry. It's really profound, really ambitious, and it makes me feel really excited. So thanks so much for being on the show.
You're making me blush. Thank you. Appreciate that. No, it is. It's again, I keep coming back to him, but he's great. I learned from Elon. Give something that has an amazing experience. And then once people get locked into that, then you can change it. You can change the chemistry of the battery. You can change the steering wheel. You can change the interface. And that's what we're doing. We're building a familiar product. And as the company grows, we'll re-engineer the materials, the doors, the roof to be even more factory-like. And that's the fun part, is you get the trust of people and you build familiarity. And then the constraints come off. And look at what Elon's doing, Cybertruck and casting parts of the car. So that's the aspirational thing. So if I step in his footsteps to get us better on housing, I'll shamelessly do that all day.
It's brilliant.
Yeah.